To begin, you start by writing the balanced chemical equation and make sure you have equal amounts of molecules on both sides of the equation. In this lesson, we will be using stoichiometry to show the relationship between oxygen and glucose, which will show how much energy is produced by breaking down glucose by oxygen. The problem states that glucose reacts with oxygen to produce water and carbon dioxide. For a complete reaction of 30 grams of glucose, what mass of oxygen in grams is required? And that would be oxygen gas. Furthermore, how many grams are formed of water and carbon dioxide as products? In other words, what are their masses? To ensure that you answer all parts of the question, it can be beneficial to create a checklist while you're solving the problem. To begin the problem, we want to find the mole of all of the reactants using the mole ratio so that we can answer the first question, which is the amount of oxygen gas required. The problem stated that we have 30 grams of glucose. So now we need to find the molar mass, or the molecular weight, of the molecule in order to be able to convert the grams of glucose into moles of glucose. Now that we found the molar mass of glucose, we can set up a conversion where we have 30 grams of the glucose that was given in the equation times, in the denominator, the molar mass of glucose, which is equivalent to 1 mole of glucose. Now we can cross out the common grams of glucose, and it leaves us with moles of glucose. Using the mole ratio, we know that 1 glucose molecule is equivalent to 6 moles of oxygen gas. Now we use the moles of glucose, which is 0.1665, and to put it in the conversion of the denominator of 1 mole of glucose to cancel out the moles of glucose over 6 moles of oxygen gas, and we get 0.999 moles of O2 required. However, we have to be careful of the units and remember that we don't want moles, we want grams. So now we take the 0.999 moles of oxygen gas required and put it in a conversion with the denominator of 1 mole of oxygen gas to cancel out, and then in the numerator, the molar mass of oxygen gas, which is 31.998 grams of O2, and then we multiply the 0.999 moles of O2 by the 31.998 grams of O2 to get the answer of 31.996 grams of oxygen gas required. Using the same concept of mole ratios, we can set up another conversion, this time comparing the moles of glucose with the moles of carbon dioxide. So we set up the same conversion with the same moles of glucose, and then we cancel it out, and then we are left with moles of CO2. Now we find the molar mass of CO2 to get the total grams of CO2, and that would lead us to the mass, which answers our second question. After multiplying, we get the answer of 43.965 grams of carbon dioxide. To answer the last question, we use the same concept with mole ratios, as 1 glucose mole is also equivalent to 6 moles of water. We use the same concepts and find the molar mass of water, and then use conversions to find the grams of water, which leads us to the mass, which turns out to be 18.087 grams of water. So the final answer is, for a complete reaction, 31.996 grams of oxygen gas is required. As a result, the production of 43.965 grams of carbon dioxide is produced, as well as 18.087 grams of water.